what we did in class today. We used a work pair to find the 6 trig ratios to find the angle that was made that gave us that ordered pair. So I actually picked 2 negative numbers. We didn't do this in class, but it'll get us ready for tomorrow. And I'm still leaving the radius at 1. We'll work more tomorrow when the radius is not 1. Okay. So first identify which quadrant is the ordered pair in. Okay, do I have a positive, negative, 2 positives, 2 negatives, or negative and a positive, positive, negative. So once I identify, okay, x is negative, y is negative, that means I'm going to be in quadrant 3. Because x and y are both negative in quadrant 3. So I'm looking for an angle. I'm going to erase this because that's a reference angle. I'm going to get into that. So I'm looking for the third quadrant. First of all, always remember to put sine, cosine, tangent on the left-hand side of your paper or in the top. And then you want cosecant, secant, and cotangent, your reciprocals, either directly below or to the right. So y over r, so the ratio of the vertical to the radius is our sine. Okay. Ratio of our horizontal x to the radius of the circle is always going to be cosine. And tangent is the ratio of our sine to our cosine or our y to x. We don't have to worry about the radius for tangent. So tangent is always going to be y over x. Cotangent is the reciprocal of tangent. So I'm going to actually go right at x to y. So this is my ratio of x to y. So once I write the ratio, then I use a calculator to actually determine what the values are. So in this case, I have 2 negatives and a positive. So I actually put in 0.4384, which is my sine, and divide by 0.8988, which is my cosine, and that gives me 0.4878. You want 4 decimal places when we're working with trig ratios. So we're looking at 4 decimal places or 4 significant digits. It is a number where we have full number, like cosecant, secant, and cotangent will give us whole numbers most of the time. So I want 4 significant digits with these. Anytime I'm looking to look at sine, cosine, and tangent, we want 4 decimal places. Sine and cosine are always going to be less than 1. That's one thing that you'll start to notice as we increase more and more. Cosecant, if I know sine, I have it written as a fraction. I'm just going to flip it because this was the reciprocal is. We flip it upside down. So make sure you don't change the sign. If it's a negative x or negative y, it's still going to be negative in your ratio. So I wrote it as 1 over negative 0.4384. And when I divided that, the calculator gave me negative 2.281. Right. Secant, which is the reciprocal of cosine. And so 1 divided by negative 0.8988 is negative 1.113. And in mind, it may have been a 2 point. This may have been a 2 with a 7 after it, whatever runs to the nearest thousand. Because we want 4 significant digits. Cotangent. Same thing. You just take the reciprocal. So what was in the denominator is now going to be in the numerator. So bottom moves to top, top comes to the bottom. And I get 2.050. Now we want to find out, okay, I've got all my ratios. So somewhere in this quadrant, so this thinks that I have this is what I have. I have a right triangle, but not a negative 0.8988, and this is a negative 4. There we go. So, we want to know what theta is. And theta is your central angle. So, we are going to use cosine inverse, and then we can always check with the sine inverse, just looking for agreement. And if there's no agreement, then we're going to determine, which one are we going to use. So, I have cosine inverse of should be negative 0.8988. means we're going to go in the opposite direction. So I'm going 154 degrees this way. Okay. And that's this angle at the bottom. I want to know what this one at the top is. So what's the coterminal angle? I'm just going to take something like 60 and subtract 154. And that will give me 206. So this is what we'll be working on tomorrow, is when I'm in the third quadrant, and the calculator is not going to tell you that it's a 206 degree angle. It'll always give you something that's between 0 and 180. So that means that I have to think about where it is, and am I going to subtract from 360? Am I going to, or am I going to do something else where I'm just changing the angle from a positive to a negative? That's it. Pause real fast. Okay, so this is a look at what we're doing tomorrow. That's when our radius is not 1. And we know it when either x, y, or both are greater than 1. So if I have two whole numbers, I have 4 and 5. So x is 4, y is 5. And that gives me, I want to find out what my radius is. And I also want to find out where theta is. Well, if x and y are both positive, so here's 4, 5, here's my 0.45. Vertical, horizontal. We're going to start drawing out the triangles now, starting tomorrow, so you get a good look at it. I'm in the first quadrant. I can try to say, okay, what's cosine inverse of 4, but what's going to happen from sine inverse of 5, you're going to get, your calculator is going to give you an error. That's if you're in degrees, because you better be in degrees with these, because when we're doing northern pair, it's not in radians, they're theta in degrees. All right, I want my radius, so that means if I have a side that's 4 and a side that's 5, I want my hypotenuse. We're going to use the Pythagorean theorem. So my radius is the square root of 5 squared plus 4 squared. So the Pythagorean theorem states that if I take the sum of the squares, and it's square root, I'm going to get that hypotenuse. Oh, I'm going to have x squared so my radius is going to be the square root of 4 squared plus 5 squared, or the square root of 16 plus 25, which is the square root of 41. And leave it like that. Don't try to make it a decimal number yet. Just leave it as square root 41. So r is root 41. So this is my r, my x, and my y. So my y is the ratio of 5 to square root 41. Once you have it written down, go ahead and convert it to a decimal answer. So I'm going to 5 divided by root 41, and I'm going to get 0.7809. Cosine is going to be the ratio of 4 to the square root of 41. I'm going to 0.6247. And then my tangent is going to be the ratio of 5 to 4, which is 1.25. cosecant, okay, is the reciprocal of this. So we're going to take the square root of 41 and 10 on the 5. I say go ahead and write everything in first and then go back and figure it out. So if I take the square root, we have 1.281. What you're going to do if you're using a calculator like this, after you hit the square root in 41, you want to hit the over key. Otherwise, when you divide by 4, it's going to be under the square root sign, and you're going to get, it's going to take the square root of the quotient, and that's not what we want. So if you're plug in square root 41, divide by 4. Last year I had we put this in parentheses. So parentheses square root 41, close parentheses, divided by 4. That would work. And then 4 divided by 5 is 0.8. So same thing. We can actually take theta is first product, so cosine inverse 0.6247. .1, 1.3, let me make sure I put it in right. This was 6247. Yep, 51.34. So theta is 51.34. And if we, most of the time, I'll say around to the nearest 10 or whole number, and that would be fine. So 51.3, 51.34. And that's what we're doing tomorrow is when R is now 1, how to find the radius, and then working with these, and getting data again. Alright. All done. See you guys tomorrow.